So this is the first lecture of the series of naive-Bayes algorithm. So before going discussing the naive-Bayes algorithm, first we have to discuss about some primary concept of the probability theory. So let's start. So in this lecture, we are going to discuss about the some primary definitions, and we have seen that some primary example about conditional probability. So first, let's start. Simple. If you just call this naive-Bayes algorithm, simple. This algorithm is a classification algorithm. And as well, it is a probabilistic approach based probabilistic based algorithm. Okay, simple. It is probability based algorithm. So in the next series of lecture, we will see that KNN, that is K nearest neighbor based algorithm, it is simple the distance based algorithm. Means in that algorithm we will choose the neighborhood based concept. Okay, that's situations we'll see in the next series of it. So first discuss the conditional probability. So we have to just read some primary concept of probability. So first, in if you just remember probability sections, there we are learn what is random variable. Okay, simple. I am not discussed again that thing. So simple. Let's take a is a simple our random variable. Okay, let's a is one random variable and b is another random variable. Now simple for probability for conditional probability. I think in 12th standard, 11 and 12th standard, and also if you are a CBSC, ICSC board student, already you are learned what is probability and how we will derive this kind of probability. Okay, now just I am omitting this primary concept. Just first I am starting from the conditional probability. So a simple conditional probability is denoted by P of A as B. Means this means that for a event that is taken by A and already a happened event that is taken by B. Simple. That means A. Just write down first, then I am discuss step by step everything. Okay. Just if you just read this thing, if you just read this thing in English, then simple it means simple. Then simple it means this thing means first we have to know what is this mean. This means if a is a random variable, and for a random variable this is a simple a particular variable value of this random variable. This is simply particular value of this random variable a. Similarly, for random variable b, this small b is a particular value, one particular value is random variable b. Okay, if we just read this thing, if you just read this thing in English, then what is this mean? This mean for a particular value of a random variable, just write down this probability of the random variable A for a particular value A, for a particular value A, if if this sign means given sign, means already happened or already given. Okay. Or in another language we call it already happened. This section if already happened, already happened. If the event for the value B is already happened, if the event for the if the event for the random variable, simple, I am using random variable simple by RV, random variable B for a particular value B is already happened or it is already given, is already happened. I think spelling is okay. HAPPEN. Okay, if you just if I have written some misspelled it, please correct it. I am not caring this English spelling about the English. Just if you understand this is the main thing. Okay, just read this thing in English. Okay, then I think this definition will be clear, and I think it will be in another language. If you just call in simple English language, if you just write this thing in simple English language, then this thing will be, that means A takes a value A if we have given a value for B, for the event B. Okay, this means simple, this means given, this means given B, given B, given simple, given I think it will be better, if given B takes a value B, if given takes a value B, if given, if these situations are we have given takes that's event means B takes a value give means, then if then, just I am writing these conditions for if then. First I am writing if this event is given B takes a value B, then this thing means then A takes a value simple A takes a value, these are the two of them. This means already happened. B takes a value B, this already happened, and now we are going to find if this already happened, then what will be the probability of A will take a value A takes, sorry, it will be A takes a value, then will be of A by. I think this thing now is clear. Okay, this is a simple mathematical transformations of the English language in mathematical. This thing means we have already given or it is already happened this event, and with respect to this event now we have to find this event, that is A is equals to A. Just I think it will be clear if we take an example. Okay. So before going take an example, just I am going to the Wikipedia page. Okay, so this is from here we are taking the example. Sample here we are taking a roll of a dice. I think you are already learned what is the dice. Dice is simple, is structure like that, like that. In each side they are have a count 1, in each side 2, in side 3. So 6 side there has 6 value. It has 6 value. So here we are taken the two events, that is two dice, same kind of two dice. Here we are using same kind of two dice here. Here this thing is that. This I am using those two similar kind of die, and it is also a, and this is also the this is same kind of die, and we are throwing this die independently. Okay, so we are now defining the two event, that is first event is called the d1 and it takes the value, if we it takes the value if we throw this die a1 first die, just I am rename it. This is the first die, this is the second die. If we throw the first die, then what value is occurred, this value takes the event d1. Okay, value of sample I am writing value of the die d1, die 1, and the d2 is the sample, it will be the value of die 2. So this is the two event we are just assume, just see this thing. So now we are defining the probability, just read this thing, just read this. So if we just first going to this, just see this chart table. So if we just throw this die 1, so what kind of value it will occur? So here 6 kind of value it will occur. So 1 up to 1 2 3 4 5 6. Similarly for die 2, so for die 1 this 6 kind of value occur. This 6 kind of value occur, and for die 2 as well here 6 kind of value occur. So if we just combine, if we just taken the pair of values, then for 6 into 6, that is total 36 pair of value we have occurred. Okay, I think this thing is clear. So if you just see the meaning of this table, so first here, if we rolled the die 1 and it is takes the value 1, if we rolled the value d1 again and if it is value 2, then this row. Okay, this means the row thing is taken by d1 values, and column means that this thing is taken by the d2 value. Okay, and this thing means, and the value of this table, just if you see the value of this table, the sum of the value of the edge die. Okay, simple, this edge will be d1 plus d2. Here we see that here we have 9 value, means our d1 occurred 3 and our d2 occurred 6. So the sum of the 3 plus 6 is equals to 9. So same, just using this kind, here we are draw this table. Just simple, I am taking the pair of values. Suppose if we have 1 and 1 for d1 1 and d for d2 1, then our sum value it will 2. Similarly to 6, if it is 6, then it will value is 12. Just I am using this thing for making this step. Okay, now just see this thing now. Okay, now just see this second table. See the second table. In second table, just probability that d1 plus d2 less than equals to 5. This means what? This thing means we have to choose the event that sum will be less than is equals to 5. Okay, just see the table. We have the value between 2 to 12. So the if we call this total table, if we call this total table is D, example, if we d is equals to d1 plus d2, and d, the value of d will be 2, 3, 4 up to 12. Now here the condition is the sum of the value will be less than is equals to 5, means our now the we have to choose that point that will take the value between 2 to 5, that is 2, 3, 4, 5. Just see this thing. This means shows that exactly 5 out of 10, means why it is they are writing for exactly 10 out of 36 outcomes. That means we actually, if we tackle the total space of this table, then it will 36 point, and if you see between 36 point we are only get the 10 cells, we are only get the 10 cells, this one, this one, this one, only these value are less than 5, less than equals to 5. Okay, so total how much number it has? So this number is 10. So what will be the probability of this thing? So the probability will be of this event, only if we consider this event, d1 plus d2 less than is equals to 5, this total outcome is 36, and out of 36 outcomes we have got only 10 outcomes. So the probability will be 10 by 36. I think this thing, are you clear? Already we have seen this kind of thing in class 12 standard, 12 year 11. Now come to the concept of conditional probability. So the first take this example. So this example means probability that d1 is equals to 2. D1, our d1 means our die 1. If we throw the die 1, then the value only occur 2. But we have given that sum of the two probability. Suppose we have two die. Suppose it is the first die and this one the second die. This means we have already given that our sum will be first condition. This means our first condition. Condition means what? If our the sum of the dice if only less than 5, then we are just consider this. Okay, if our sum of this event, if we just roll down two dice, if the sum is less than only less than is equals to 5, then only we are consider. And which between this event, which thing we have only consider, which kind of things we have to consider. If for die 1, if this 1 5, then we have to consider, then we only consider for d1 is equals to 2. These simple things, if you just read this simple thing in English language, just you got this. If we have given conditions that if our dice of, if we throw these two dice and only the sum of the two value, sum of this value will be only less than 5, then we are just considering this event. And in these events, which point we are considering, if our d1 just first, if our first die only occur in 2, so what will be now the probability of? So if you just write this thing, mathematically, if you just write this thing in mathematically, so the mathematics would be our d1 is equals to 2 given our d1 plus d2, that will be less than is equals to 5. This means that, so this sample we have already learned, that this thing means given, we have already given this portion, and or another language this thing means conditioned int, or already happened, or conditioned. Okay, so Now what will be this thing? Just see this picture, just see this picture geometrically first. So the what will be this? First we have to consider this given condition. Okay, first we have to consider this given. So what will be the event points of this condition? So just see. So our first we have to choose this event that less than is equals to 5. So number of events will be this one, this one, this one. So in previously we have seen that this will be 10 points, only 10 points. This thing will be only 10 points. And on these 10 points, this is already given. This is our condition. This thing is our condition. And on these conditions we have to find that on these conditions where only when our die 1 will be 2, only die. Just see this one, this thing, where here only 2, this means this row. In this row only our die 1 will be 2. So what will be this event? Only we got the between these 10 events, only we got the 3 events. So the total probability will be 3 by 10. Okay. So just in mathematical, it is we saw this with the condition probability concept in geometrically. Now see this thing in mathematical. So let's take our first probability is d1 will be 2. Let's take this probability, value of this probability is equals to a. This means this event means this is our event, or in another language this is our random variable. And our second thing is d1 plus d2, that is our already conditions or given, is equals to 5. And this thing is our second random variable b, that we call b rand b. So now we are interested to find this probability, means probability of a with given b, with condition to b. Okay, just see, means what we this definitions of this probability means we have seen that between first we have to choose the probability of b, means first we have to find this probability, this event of this probability, and under this event of probability we have to find this probability, means the intersections of these two things. So we have to find these intersections of them. Okay, so what will be the intersection value of this? Just see this thing first. We are interested to calculate probability. So what will be probability of this b? Probability of b means what? Probability means this one, this thing. What is the probability of this thing? Means totally, just we are first calculate the probability. Okay, first we are interested to calculate the probability b. So probability will we have total 36 outcomes, and on this 36 outcome only we are considering these events, means we are considering these 10 events, only this content. Then only for these 10 events our sum of this probability, sum of this value will be less than is equals to 5. So only 10. So probability, we got the probability of b. Now we are interested to calculate the probability of a intersection. We see that this total thing is our b. These total things is our b. Now we are interested to calculate it, this one. On this probability of b we are now interested only for this d is equals to 2, means this one only, then our d will be 2, only d1 is equals to 2, only this means. So total the value will be now, so what will be the value? We have total for b, we have total how much point? Total 36 outcomes, and on the 36 outcome our a intersection b will be 3 values, only 3 values. So this will be, now if we just put this value here, our numerator value will be 3 by 36 and denominator value will be 10 by 36. So the total final outcome will be, this 36 will be cancelled out, 3 by 10. So just see it, this value is if you just remember the geometrical concept, then this thing we are already got this value, and the same value if you use the condition probability definition, the same value we have already got. I think the simple geometrical and intuitions of the probability, conditional probabilities concept is clear, all of you. Okay, now applying these things, now how we calculated the naive Bayes, how we just construct the naive Bayes classifier algorithm. So we'll see in the next part of this lecture. Okay.